Good afternoon, everyone. I'm Jake Spiegler, and I'd like to welcome you to our 5th KM KSU webinar. I'm a graduate student in the master's program and will be one of your event facilitators over the next year. The KM KSU webinars are an open forum for anyone engaged or interested in knowledge management or knowledge sciences. In this community, we define knowledge sciences broadly and inclusively. Events and webinars are offered to expand the dialogue and also to provide exposure to people and organizations who are doing great things in this area to advance ideas and to discuss challenges. We want this to be your forum, so we encourage you to propose events, suggest topics, events, as we mentioned in our kickoff session, are not limited to presentations, but can also be open conversations and discussions, interviews, and so on. We're receiving many very interesting suggestions, and we have volunteers for over half a dozen events. Please do keep the ideas coming. This is an open forum which operates under a Creative Commons governance model. It is also a community without formal funding, so I want to always take the time to acknowledge the contributions of our team here at Kent State, including Jenna Corenzo, our academic program coordinator, Nicole Stempek, our graduate assistants, and now I'd like to introduce you to our speaker for today. Our speaker today is Adrian Walker. He is the CTO of Reengineering LLC, and he works with Internet Business Logic. In the past, Adrian has been a member of the technical staff at Bell Labs, the manager of principles and applications of logic programming at IBM Yorktown Heights Research Laboratory, and an assistant professor at Rutgers University. His educational background includes a bachelor's degree in electrical engineering from Sheffield University, a master's degree in systems engineering from the University of Surrey, and a PhD in computer sciences from the State University of New York. And now I'd like to hand it over to Adrian.
Thank you very much, Jake, and hello, everybody. I hope you're seeing on your screen the first slide of the presentation today about sharing knowledge as apps in executable English. And between executable and English on that first slide, you should see the phrase open vocabulary, and we'll be explaining a little bit more about what that means. And to see that we're actually sharing knowledge that has some industrial strength to it, we'll have first a simple example and then an example of the oil industry supply chain in executable English. So going to the second slide, we'll talk first about making smart connections. That's apps connecting people and data, and not just users of the apps, but users and writers of apps now sort of become somewhat the same group of people. Then we'll talk about knowledge in open vocabulary executable English and give a simple taxonomy example of that. And we'll go to the more detailed oil industry supply chain example. And we'll note that once you make a representation shift, instead of writing apps in Java or similar, you write them in executable English, you find that some good things sort of happen serendipitously, which is that Google indexes and retrieves knowledge in executable English. So it acts as a kind of registry. And finally, we'll show how executable English can be used to query networked distributed SQL databases and give English explanations of the results without anybody ever having to write SQL. They just have to write in executable English, and the system translates to SQL as needed. So moving on slide 3 here, we're just noting that good things happen when we make smart connections. So many people in the IT world will be aware that the Linux operating system really revolutionized what was going on in that in order to run a Unix-type system, you no longer needed a big, heavy piece of hardware, but a laptop PC would be fine. Then, of course, Google is famous for connecting people and web pages on the net, and eBay for connecting buyers and sellers. And so another way of making smart connections, we hope, is this idea of open executable English apps. Moving on to slide 4, there's a sort of fairly well-known chasm like the Grand Canyon between business, bottom right, and IT, top left. And so another way of looking at what we're trying to do today is on slide 5, where we use executable English to try to bridge that very expensive gap between business and IT. it's important to make these connections between business and IT, because you get into a situation where, for instance, data.gov, which is opening government data, a very worthy thing to do, very interesting. But what you find on data.gov is raw data in many different formats, some UIs, but the situation is that most of that data is only useful to developers, while we have lots of people with knowledge out there who, if they could find enough developers to write the code for them, would be making new apps above the 1,000 apps and counting already there. So the situation is that applications actually assign useful meaning to data. Going on to slide 7, we'll talk a little bit now about writing applications in English, running them, and getting English explanations. And we'll do that using a simple taxonomy example. So the idea on slide 8 here is that it should be possible for an end user or a business analyst to type in knowledge such as that in the yellow oval where product X and Z can be substituted for product Y, but only in the full. And the idea is to allow him to write, or her, to write business rules directly into a browser, run the rules using the browser, and see English explanations of the results. So just to go into a little bit to sketch out what has to be behind that browser page, go to slide 8. First of all, there's a theory of declarative knowledge that was developed by myself and others at IBM way back when, and it basically informs the programmer who's going to program the system that supports the browser. So you've got semantics 3, English, top left. You've got semantics 2, this theory of basically what it should be possible to infer from a bunch of logic statements. And that informs the programmer who programmed, going to slide 10 now, the Internet Business Logic System, which is application independent, because the guy on the left there is specifying what the application is, and is specifying it in English that happens to be executable. There's an additional semantics to be taken into account. We can call it semantics 1, which is what the data mean by themselves. And very often, one's familiar with SQL databases that are really difficult to understand unless they're provided with good English documentation. So you often find a database, but you have to go off and find the notes that the programmers wrote when they set up the database. And we'll see how we get around that with assigning semantics 1 to SQL or RDF data. Going to slide 12, a summary of this idea of using open vocabulary. So there's no external dictionary or grammar maintenance needed at all. The strict English semantics is achieved via trade-off. So the trade-off is if you're writing and you want two English sentences to mean the same thing, you actually have to say so explicitly. And you must use placeholders, which are sort of act as variables in the middle of the English, and they read as some name or a number or things like that. So if you make that trade-off, you're then free to write executable English knowledge in containing technical terms that there's really no dictionary for. For instance, if you're in the oil industry, wildcat has a meaning completely different from a wildcat running around in nature. Mud also has a technical meaning in the oil industry. So the design of the system has been specially sort of slanted towards the idea that people can just write down their knowledge and run it without having to go to a dictionary and update what wildcat means in the context of the oil industry or anything like that. This idea of the vocabulary being open and the syntax also means that you can also directly go to use, say, government acronyms or military acronyms. And you can even do things that sound a little crazy, perhaps, like writing logic expressions in the middle of your English. And we'll see a little bit about how that works. So although the system is open vocabulary, it can be used to query and manage controlled vocabularies, taxonomies, and ontologies. Going to slide 13, we'll go to a simple taxonomy example to try and illustrate how this thing works. So on slide 14, there's a diagram at the top, and it says here's a little situation in which Adrian, Bob, and Claire are researchers, and they do research on something on the left, the 4 orange ovals, which is a little taxonomy of semantic web activities, if you will. So there's knowledge discovery, there's data mining, there's text mining, and the blue arrows pointing upwards indicate knowledge discovery is a subtopic of semantic web, data mining of knowledge discovery, text mining of knowledge discovery. So to see how this can get very technical even in the short example, a new user asked, how can I use these particular tools to find out from the above that Bob does research into the semantic web? So it's nice to sort of follow the graph from Bob to data mining to knowledge discovery to semantic web. And that ought to be quite easy, but in the present state of the technology, you really need a programmer who knows his or her stuff to answer the question, does Bob do research into the semantic web? Going to slide 15, we're starting now to write executable English for the bits of that diagram that we saw before. So the diagram with the little sort of taxonomy of semantic web activities can be summarized by typing into a browser the items in green at the bottom. So we make an English heading saying this item is a subtopic of this topic, and we write down data mining as a subtopic of knowledge discovery, and so on. So to continue trying to cover that diagram, we need is a researcher. That's another little sort of ontology, if you will. And we also need the facts for does research on, and that's a table with an English heading, this person does research into this topic, Adrian, Bob, Claire, and the topics they do research into. So now we've got in executable English 3 tables that summarize the diagram above. If we go to slide 18, there's one other thing. We said that we like to chase the diagram from Bob to data mining to knowledge discovery to semantic web. And we can do that by writing a rule. If some subject is a subtopic of a subject 1, and that subject 1 is a subtopic of some topic, then that subject is a subtopic of that topic. And with that rule and those facts, we can ask, we need one more rule, which is that if some person does research into some subject, and that subject is a subtopic of some topic, then that person does research on that topic. So now what we've got is enough information to answer the question, what topics does Bob do research into? And if we just go to see this live for a moment, if you're in the system and you choose our research on and go to view or change it, what you see is some commentary in the first panel, and then further down, what you see is the rules and facts that we've just been talking about. So there they are, and so if you wrote that into your browser and you said, I want to run this, the system will come back with a menu of questions you could ask. You can type in anything you like here, or you can just go straight to some person does research into some topic, and driven off the rules that you've seen so far is little menus like this, and then you can ask, and the answer is that Bob does research into these 3 topics. And if you ask for an explanation, the explanation comes back that Bob does research into data mining, and data mining is a subtopic of the semantic web, so Bob does research into semantic web. And this line here is actually a hyperlink. And in general, these explanations can get long, and the hyperlinks help you to navigate through them. So that's just running a little example. And we'll go back to the slides now. So Bob does research into some topic. We just saw the system working and answering like that. Slide 21. And on slide 22 and 23, we see the explanation of that answer. So the idea is to be able then to write things like this into a web page and have them run immediately without any need to build a dictionary, without any need to find a programmer to help us to do that. So that sort of summarizes how a simple example would work. It does work, indeed. And to make things a little more real, here's an example that we developed with a guy at Shell, just taking some of the things that you have to consider, the knowledge that you have to consider when you're doing supply chain for the oil industry. So it's a complicated business. There are refineries, there are terminals, there's transport, there's eventually everything gets to a service station. And these slides must have been made when the gas price was about $3.30, which would be nice if it was still true today. The oil industry example that we're looking at is that a customer needs some number of gallons of a product Y. But you can mix together gasoline products under certain circumstances, so products X and Z can be substituted for product Y, but only in the fall. And what you need to do is to combine the products to fill the order. And the combination depends on how much of each product is available from each refinery, and do we have the transport to do that. So in the same style as the simple taxonomy example, here are some facts about the oil industry supply chain that we're looking at. So somebody wants 1,000 gallons of product Y. In this season, product Y can be fulfilled with product X or product C as long as you're in the fall. And here's what the refinery has scheduled to make available. And here are the transportation methods that we have. So the rules that we can write to use those tables of data are fairly straightforward. They get into sort of knowledge that maybe somebody might have before retiring from Shell, and if they wrote it up this way and made it runnable as an example, this might be a useful educational tool for people who come along later. Or indeed, it might be a good tool to be able to have different people inside an oil industry, an oil company, cooperating to write sort of wiki style, to write these rules, run them, see if they make sense. If they don't, improve them and continue on. So with some rules like that, we can say, okay, how are you going to fill that demand? And the system comes back with an answer table like that. And if we look at that live, so here's sort of summary English, and here is the actual executable English. Goes on for a little bit. Here are the tables of data. So that's a whole application that's beginning to do something that might be useful in the real world. So if we go to run that example, the system comes up with a menu, and we could type sort of how to fill order in there, and the system would come back and suggest that maybe that was what you were asking about. But we'll just take the menu before trying to reorder it with a pre-question and say, this is really what we want to ask about. And if we go ahead and ask that, we get the answer table that we just saw in the slides. And if we then go and say, if I'm using product Z partly for product Y, I want to know how I can get away with that. The explanation comes up like this. And here you see that the explanation is hypertexted so that you can jump around in it and see the justification going through the rules all the way back to the data. And some of these explanations can actually be viewed as plans. So when you say, can I fill this order, you can view the explanation as a plan for a detailed plan for how to fill it. So it will tell you what transportation you should be using and so on. So going back to the slides now, we just saw that answer table, and here's the explanation. And we said that once you put examples like this online and open them up to Google and other search engines, what you find is that Google indexes and retrieves the knowledge. So this, of course, varies because Google search is changing all the time. But roughly speaking, if you type in a sentence that looks like what was in the knowledge there, then Google will come back and find the knowledge. And actually, in this case, it's also found a paper that describes that application. So once you do things on the web like this, some very surprising and powerful things sort of come from the shift in representation from code, from program code to executable English. We said that the system can generate SQL. So the tables that we looked at were fairly small tables. There was really no need for performance reasons to put them in a database. But just as an illustration, we'll say if we move from just typing a table directly into the browser and go instead to say the table is already out there on the internet, I just want to put in a rule that says how to find it. So if we substitute tables like that for rules like this that say, okay, to find the method of transportation, go to example.com, find a DBS, find an Oracle database with a certain name, find a table T1 in that, and some more details, then the system can use that information to actually generate SQL automatically, send it over the net and run it, and have the host database run it and come back with the information that we need on transportation. So if we look at that live, this is very like the last example, except that where we used to have the actual data present, this time we have these linking rules that say, if you can find that data on the internet, this last line is what it means, what the semantics are, if you will, for that data. So if we go and run that, we'll see that from the user point of view, it looks exactly the same as when we weren't using a database. We just get the same answer and the same explanations. But when we view or change the agent, as we said, there's no longer any data present where we're running the rules. The data is all pulled live off the web using these linking rules. So if we go back to the slides for a moment, there's a rule that says how to find the table on the internet. And if we run it, this is what's happening underneath the covers, if you will. So nobody ever needs to see or understand this. But this is some of the SQL that was run in order to get that example. So this is in the spirit, again, of sort of removing programmers from the loop so that we can go straight from a business analyst type person typing business rules into a browser and have things like this happen automatically underneath the covers to answer his or her questions. And explanations come back the same, even though the heavy lifting was done by a SQL database. So we've looked at automatic generation of distributed SQL with English explanations of the results. And so that comes back really to saying the system is out there. We hope that people will increasingly use it cooperatively. If you think about the directions of social media, we have Facebook. You can type English into Facebook and other people can read it. We have Twitter, likewise. This is maybe a step in a different direction, which sort of opens up all sorts of possibilities, like the one we saw where Google was automatically searching for agents written as rules and facts like this in executable English. So we have actually set up an ID that folks at KSU and related summaries can use, and that ID is, let's see, so you can log on to the system with the ID KM at KSU and the password KM author, and you're welcome to try out the examples that are there, and of course to write and run your own examples. So that completes the presentation. Thank you for your attention, and any questions, please.
Well, it looks like we don't have any questions, but I definitely going to take a look at the examples you provided here. It definitely seems something I can play around with, maybe learn a little bit.
Yes, please.
Okay. Well, on that note, though, I'd like to thank you for your time, Adrian, for giving us this presentation and expanding the knowledge of the KM KSU webinars. So on that note, I guess we can end the session.
I'll be following the next presentations with great interest. Thank you very much, Jake and Denise.
Okay, thank you.
Okay, hanging up now. Bye.